Hello, everyone. So we are Group 10. We are presenting the churn analysis using PrisDM that we have made for Smarter. So I am Anthony Catindig Jr. and here are my group mates Julio Emilio de la Cruz and Gerson Villamin III.
Who is who is Smarter? So Smarter is a small mobile telecommunication provider who is operating in North American market. So Smarter Executive Board, their executive board consists of senior executives with a range of technical sophistication and domain expertise along with some senior executives who have been with the telco for over 20 years and others who have just joined recently.
What they want. They are interested in the characteristic of those customer who churned and did not churn. Whether churn amount rate was different at a certain amount of revenue levels. Data visualization on the characteristic of customers who churned and did not churn. Whether those that churned have higher levels of drop calls, at least 5 recommendations for the company to help them on how to make those customers who churned for them to stay.
So our solution, we will use PrisDM framework to effectively analyze the problem and provide a recommendation for Smarter to help them make their customers return for them to stay. So this is the PrisDM framework. So PrisDM, also known as Cross-Industry Standard Process for Data Mining. So it is an industry-proven way that guides a team on their data mining efforts. So the following are the phases of PrisDM. So first is the business understanding. Next is data understanding, data preparation, modeling, evaluation, and deployment.
Data understanding. They have provided us a data documentation containing information about the records to help us in analyzing the given dataset. And the datasets contain 58 features and approximately 50,000 records. Um, we have first converted the data into a CSV file and loaded it in Python using Jupyter Notebook.
So as you can see in the screen, this is the first row of the data set. So there are 144 null values in the data set from the columns above, which we filled using the mean value for each column.
So we have also seen several several rows in the age column that has a zero value. So we have replaced those zero values in the age column using its mean value. So we also get the correlation of the variables in our target variable, which is turned using the heat map. So from the zero point 0.9 perspective on the heat map, we have seen in the graph that there are certain columns that has a multicollinearity problem, and they are the radicals and radicals, which has a 0.96 correlation. Male ord and male rest, which have 0.97 correlation. So we have removed one for each pair of columns that has a high collinearity, as it can affect the prediction performance of our model later on. So this is how we drop the those columns that has some collinearity problem with each other.
Dropping the customer column since it only represents the ID of the customer.
So we also seen that the columns that can be merged. So credit A and credit AA into credit rating. So 0 is for credit A and 1 is for credit AA. Also, merging columns that are related also on Prism Rural, Prism Suburban, and Prism Town into Prism Code. So the Prism Rural is for 0, 1 for Prism Suburban, and 2 is for Prism Town.
So we have also merged the different occupation types, which are the occupation professional, occupation clerical, occupation craft, occupation student, occupation homemaker, occupation retired, and occupation self-employed. So 0 for occupation is professional, 1 for occupation is clerical, 2 for occupation is craft, 3 for occupation is student, 4 for occupation is homemaker, 5 for occupation is retired, and 6 for occupation is self-employed. So we also merge the the two different marital status, which is the marital status unknown and marital status is married. So 0 for the marital status is unknown and 1 for marital status is married.
And we also merge the columns that are related to each other, new cell Y and new cell N, into new cell user type. 0 for new cell N and 1 for new cell Y.
So based on the above pivot tables, we have seen that the customer who did not churn is lower even if the voice calls are dropped, blocked, or unanswered.
So based on the graphs above, we have seen that the revenue from previous month based on the churn status, those who have higher revenue have churned, and in terms of months in service based on churn, those who have had service from for the those who have higher service in the previous months also churned. And lastly, for the customers income based on churn, we have seen that it doesn't affect at all the churn status of the customer, since those who have higher income didn't churn.
As we can see in the graph above, that 59.7% of the customers of Smarter did not churn and 40.3% of them churned within the last month.
So churn based on months in service. So we can see on the graph here that the maximum churning happened after 10 to 14 months of service.
So churn based on drop or black calls. So violet is for the for those customers that have churned, and green for those customers that did not churn. So it can be observed on the graph above that the lower number of drop or black calls have the most churn occurrence.
Churn based on customers' occupation type. It can be observed here that customers who have occupation type of professional, which is 0, have the highest churn rate.
So churn based on customers' marital status. So it can be observed on the graph above that the customers who have unknown marital status have the highest churn rate.
So churn based on cell phone user type. It can observe that the customers who are known not to be a new cell phone user have the highest churn rate.
Churn based on age. It can be observed here that customers who are around the age of 35 to 44 churns the most.
So churn versus voice calls. So we can see here, the blue is for the black voice call, orange for drop voice call, and green for the unanswered voice call. So as we can see, that the unanswered voice calls have the highest number of customers who didn't churn and customers who have churned. So this is the churn versus inbound and outbound calls. So blue is for the in calls and orange for the out calls. So we can see here that the out calls or the outbound calls have the highest number of customers who churned and did not churn.
So in this graph is the churn versus credit rating. So the 0 is the credit A and the 1 is the credit AA. We can observe that the credit rating, which is credit A, have the highest churn rate.
So churn versus vehicle owned. So blue for motorcycle, orange for recreational vehicle, and green for truck. So we can see here that the customers who owns a truck have the highest number of churn rate and did not churn rate.
Modeling. Splitting the data into train and test data wherein 70% will go to the train data and 30% will go to the test data. We have first stored the data into X and Y, wherein X is the location for the independent variables and Y is for the churn column. Next, we split the data into train and test the data. 70% of the data will go to the train data and 30% will go to the test data. We have also normalized the train and test the data using min-max scaler to make the data more uniform. After that, we have used the random forest classifier to get the feature importance of the dataset.
So feature importance using random forest. So based on the result, we can see that the occupation type has the highest feature importance, followed by demand in service and the number of days of the current equipment is in use.
So we have used different algorithms such as the logistic regression, k-nearest neighbors, support vector machine decision tree, and naive Bayes. So based on the result of the prediction on those models, the decision tree is the best models for predicting the churn, having an 85% accuracy score. So these are the actual and predicted values for the first 20 rows of the churn in the data set. So as we can see, there are no significant changes in the first 20 rows after the prediction.
So decision tree model, we also plotted in order to see how the prediction happened.
Score based on different metrics. Using different score metrics, we have seen that the decision tree have performed well in predicting the churn.
So the accuracy score for the decision tree is 83.88, for precision 87.44, recall 70.27, and F1 score is 77.92. So based on this graph, we can see we have also created confusion matrix to see the predictions that the decision tree has made. So 0 stands for those who did not churn, and 1 for those customers that have churned. So the color black box is for the true positive, true positive, true negative, and for the white is for false positive, the blue is for the true positive, and brown is for false negative. So there are 8,258 observations that tells that the customer did not churn and predicted to have not churned. So for false positive, there are 609 observations that tells that the customer churned but predicted to have not churned. For the true positive, we have 1,793 observations that tells that the customer have churned and predicted to have churned. For the false negative, there are 4,283 observations, 38 observations that tells that the customer did not churn but predicted to have churned.
Recommendations. We have concluded that most of the customers who who churned have the occupation type of professionals, had 10 to 14 months of service from Smarter, around 35 to 34 years old, unknown marital status, known to be a new cell phone user, and those who have been using their current equipment for a longer time. Focus on their service to customers who are professionals, provide the customers with a new offers after 10 to 14 months of service that may help them stay, create a plan or offers for customers who are late adults, try consulting their customers who are not yet married or have an unknown status, creating an offer for customers who are not new cell phone users, issuing new equipment for customers who have been using their current equipment for the longer time.
So that's all for our presentation, and thank you.
Thank you.